Hi guys, so for today's lesson we're going to be dealing with Venn diagrams in our probability topic. So first up, what's a Venn diagram? So it's a tool used to represent situations with two or more overlapping events. So, for example, like to describe this word overlapping, consider the following two events. So, the first event is that a random person likes rugby. So you've picked a random person, and the event is whether they like rugby or not. And the other event is whether a random person likes cricket or not. Now, we consider these two events that we're investigating to be overlapping events because someone can like rugby and cricket at the same time. So they can kind of tick both of these. So when this is a possibility, they can also dislike both of them as well. That's an option. So when you're dealing with these sorts of overlapping events, we like to represent them in a Venn diagram to represent sort of the different things that people can kind of choose with these questions. Okay, so our Venn diagram consists of a box and two circles. And when you do that, it actually makes 4 different regions. The first region is the sort of outside region, and that represents that they like neither sport in this case. You've got the red circle. So the red circle represents the liking rugby. So if you're in this circle, you like rugby. This green circle represents cricket. So if you're in that, you like cricket. Notice that with the circles, there's actually 3 regions. You've got this region here, which is in the red circle. It's like on this part of the red circle. So that's if you like rugby only, but you don't like cricket. This part here is if you like cricket only, but you don't like rugby. If you like cricket, but you don't like rugby. And this section in between where they overlap is where if you like both. So you've got 1 region, 2 region, 3 region, 4 region. So it's really important to understand what each of those regions for the diagram means. Okay, next word I need you to remember is mutually exclusive events. So these are 2 events that do not occur at the same time, i.e. the overlapping section just doesn't exist. You can't like both of the events at the same time. It just isn't possible. And this is what it looks like in a Venn diagram. Literally, the events are completely separate. There's no way that you can be in both circles at the same time. There's no overlapping part. You can still like neither, but there's only going to be 3 regions in this case when it's mutually exclusive. Complementary events, they're events which are the opposite of each other. So the complement of event A is the event not A. So the idea is that A and not A are what we consider complementary events because they're the opposite of each other. Another way of the sort of notation for not A is A dash. So the dash means that it's kind of like it's the opposite of A. It's like a dash means the word not. This is a really important thing to note, that the probability of the complement of A, so the probability of not A, we can calculate that by doing 1 minus the probability of the original A. So it's like the idea, yeah. So look, this will be used a lot in future lessons, but it is an important idea that if we want to figure out the probability of not A, we can just take away the probability of the original event A from 1. Okay, so let's get some example questions out of the way. So consider the following Venn diagram. So this Venn diagram, we've got the events A and B. They could literally be anything. We don't know what the events are, so we're just calling them A and B. Shade the region that represents the complement of A or not A. So the answer here is I want to circle everything. I want to color in. I want to shade everything that's not A. So notice how A has not been shaded. It's just left blank, but everything else has been shaded in. So that's what I mean by not A. Everything that is not the circle A has been shaded. Next one is A or B. So I literally want anything that's in the A circle or the B circle. So that's where you pretty much shade in both circles fully, because we just want to be in A or B. It doesn't matter which one. Like, for example, if we're in this circle, we're in A, so that does tick A or B. And if we're over here, we're in B, so that does like satisfy the area A or B. And if you're in the middle, you're in A and B, you're still like in one of these circles, so it's still fine. You're actually in both. Okay, question 2. A number from 1 to 8 is picked at random. So this is sort of the experiment. And now we've got some events. So event A is if you pick any of these numbers. And event B is if you pick any of these numbers. So we've got 2 certain events. The first question is represent this situation, these events, as a Venn diagram. So what we do is we literally put these numbers into their correct sections. And remember, we've got 4 sections here. Okay, so let's think about this. So event A is 5, 6, 7, 8, and event B is odd numbers. We like to do the overlapping part first. What is in both? So the way that I think about it, well, the odd numbers from 1 to 8 is going to be 1, 3, 5, 7. So that's another way of describing event B. And we got to think which ones are in both. Well, 5 is in both, and 7 is in both. So therefore, 5 and 7 have to go in the center part where it overlaps both A and B. Next up, what is in the A only section? So we've already done 5 and 7. That means that 6 and 8 are still in A, but they're not in B. So I'm dealing with the rest of event A first, 6 and 8. So I put 6 and 8 right here in the A only part. Now let's deal with the parts that are only in B. So I've already dealt with 5 and 7, they're in the middle. But 1 and 3, that's in B only, they're not in A. So I'm putting those numbers in the B only section. And now once I've done that, I got to think to myself, well, I've dealt with 6, 8, 5, 7, 1 and 3. Which numbers haven't I dealt with from 1 to 8? And the answer there is 2 and 4. So 2 and 4 are in neither A or B. So therefore they go on the outside. And then we're done. Okay, so moving on. I'll just get rid of those. Okay, so use this Venn diagram to determine the following probabilities. Okay, so what is the probability of A and B? So the idea is we want to look at the A and B section. A and B means that it's in both circles. So it's just the 5 and 7 part. And we've got to think, what's the chance that we're going to get a number in this section? Well, there's 2 numbers in the section. So 2 is on top of our fraction when we're doing probabilities. And on the bottom is the total number of different possibilities. There's 8 different numbers to choose from. So there's 2 numbers out of a total of 8. So our probability is 2 eighths, and that simplifies to 1/4. Let's try the next one, the probability of B. So this is where we look at the B circle. So this is our B circle right here. Doesn't have to be just B only, it's just the whole B circle. So it does include this central part. So looking at the B circle, there's 4 numbers in here. It's going to be 4 out of a total of 8 different numbers. So the probability of getting something in B is 1/2. Done. Question C, are the events A and B mutually exclusive? So that means, mutually exclusive means that that A and B can't occur at the same time. However, if we look at our diagram, they can occur at the same time. If you pick 5 or 7, you've got A and B at the same time. So there is stuff in the overlapping section. So the answer is no. There are outcomes in both A and B. 5 and 7 mean that they're not mutually exclusive. Mutually exclusive means that there can't be any overlap. Okay, question 3. This is a very typical sort of question, but they can get a little bit weird and tricky, so really listen carefully for this one. So from a class of 30 students, 16 students like netball, 19 students like rugby, and 5 students like neither. You want to be able to display this information on a Venn diagram. So what we need to think of, remember the 4 different regions. We've got to get the right sort of numbers. And remember, these numbers that we're getting need to add up to our 30 students, because all these 30 students are going to be sitting in one of these sections. This section, remember, is if they like neither. This section is if they like, sorry, I'm going to change that A. That A is going to represent netball. So I'll write that in. It's really important to label these circles. Netball. And this one here is going to be rugby. I'll get rid of that B. Okay, so so these sections, I'll start again. These sections, this section here is if they like neither. This is if they like netball only. This is if they like both. And this is if they like rugby only. Okay, so how do we get these numbers? So the way to do it, well, firstly, you want to look at your information and see if any of them give you one of these regions straight away. So we know that there are 30 students. That doesn't tell us anything about these four four sections. We just know that they all add up to 30. Next up is 16 students like netball. That just tells us that in the whole netball circle, there's 16 students. As you can see here, 6 and 10 makes our 16. But we don't know how to get these numbers in particular. Next up is rugby. 19 students like rugby. So we know that in the rugby circle, there's 19 kids. But we still don't know how we got 10 and 9. And then there's 5 students that like neither. So that means we can straight away put this 5 into our outside region. So that's where you want to start. So start with the neither region. 5 students in there. Now, because there's 5 students out here, that means that there must be 25 students that like netball or rugby. So 6, 10, 9, that adds up to 25. The way that I got 25 was that I knew that there was 30 students altogether. So I took away these 5 students, and I got that 25 students must be inside the circles. Next up, this is the hard part. So we want to try and, now that we've got this part here, 5, we want to now go for the center part, that like netball and rugby. So how do we do that? Well, netball and rugby, the way, I figured out that there was 10 students in the middle. And the way that I do that is I add up the 16 and the 19 students that like netball and rugby. So that's 35 students when I get that. But there's only 30. There can't possibly be 35 students if I add them together like that. So the thing is, I need there to be only 25 students inside the circles. But when I add them together, I get 35. That is suggesting that there's 10 students too many, because I'm getting 35 when I should only have 25. So 10 students too many means that there's 10 students that like both. So there's 10 in the center. Okay, so now that I've got that 10, that's going to make things a lot easier. So netball only section, this section here. Well, I know that there's 10 here in the middle, and I know that there needs to be 16 altogether in the total circle. So if I've got 10 here and I need 16, I know that there's going to be an extra 6 here. So that means that there's 6 students in the netball only section. And similar to rugby, we've got 19 students liking rugby. I've already got 10 of them, so I need there to be an extra 9 outside to get my 19 students. And so therefore I finally got all 4 of my sections done. So there's my completed Venn diagram. Okay, question B. Determine the following probabilities. Now we're going to be using the Venn diagram for this. This is why we like to make Venn diagrams, because it makes this process easier for finding probabilities. So what's the probability of A only? So sorry, I'm gonna fix that up. So instead of A, I want it to be netball only. My bad. Netball only. Okay, so netball only. Which region is that? So that is this region here. So 6. So there's 6 kids in that region out of a total of 30 students. So 6 out of 30, that simplifies to 1/5 chance that you're going to get a kid that likes netball only. Let's do question B now. So the probability of A or B. So A or B, that's pretty much they like netball or rugby. It doesn't matter which. So you're literally wanting to be adding up the number of kids in these 3 sections. So A or B, you're going to be adding the 6, the 10 and the 9. That makes a total of 25 out of the total of 30 kids. And that simplifies to a 5 in 6 chance that getting a kid that likes netball or rugby. So hopefully this helps. So sorry, and I'll fix that up. Instead of A or B, it was netball or rugby. So hopefully this video helps. Good luck with the questions.